Measurement of power and power factor of a balanced three-phase load. 2-wattmeter method. A three-phased balanced voltage is applied on a balanced three-phase load when the current in each phase is going to lag by an angle phi behind corresponding phase voltage. Now we have connected two wattmeters W1 and W2 here. As the current coil of W1, wattmeter 1 is connected in R, W1 is going to read the current IR, and the potential coil of the wattmeter 1 is connected between R and Y, so W1 reads the voltage between R and Y, which is given by VRN minus VYN. The wattmeter 2 current coil is connected in phase B, so it's going to read the current IB. The potential coil of the wattmeter 2 is connected in between B and Y, so it's going to read VBY. The angle between these two, if you observe the phasor diagram, it will be 30 plus phi. The angle between IB and VBY, if you see from the phasor diagram, it is 30 degrees minus phi. Then wattmeter 1 is going to read the power V or Y IR, and the angle between these two, cos of 30 plus phi. Now wattmeter 2 W2 is going to read V BY IB, and the cos of the angle between these two, 30 minus phi. As the load is balanced, IR equals to IB equals to IY equals to I, and VRY equals to VBY. Then W1 equals to, this is nothing but the line voltage, so the line voltage multiplied by the line current or phase current. Since it is a star connection, line current equals to phase current, cos of 30 plus phi. Similarly, W2 equals to VL IL cos 30 minus phi. Now let us find out W1 plus W2, which equals to VL IL of cos 30 plus phi minus cos 30 minus phi. So plus cos 30 minus phi. Now elaborate this. VL IL of cos 30 cos phi minus sin 30 sin phi. But cos A plus B equals to cos A cos B minus sin A sin B. Similarly, write for this cos 30 cos phi plus sin 30 sin pi. Now if you observe, these two values are equal and opposite, so you can cancel these two. Then you'll be getting VL IL of 2 times of cos 30. Cos 30 is nothing but root 3 by 2 of cos phi. Root 3 times VL IL cos phi, which is nothing but W1 plus W2. This is nothing but the total power measured by the two wattmeters. Thus we can say that the sum of the readings of two wattmeters whose current coils are connected in series with two phases and whose potential coils gets potential difference between these two phases with respect to the third phase provides the total power of a balanced three-phase circuit. Now find out the difference W2 minus W1, then you will be getting EL IL of 2 times of sin 30 sin pi. Now VL IL sin 30 is nothing but 1 by 2 and 2 gets cancelled, then you will be getting sin pi. Now let it be equation number 1 and this be equation number 2. Then equation number 2 divided by equation number 1 is going to give us W2 minus W1 divided by W2 plus W1, which equals to VL IL sin phi divided by root 3 times of VL IL cos phi. Rewriting this equation, we will be getting sin phi by cos phi, which is nothing but tan phi, which equals to, I am getting this root 3 this side, then root 3 W2 minus W1 divided by W2 plus W1. Now phi equals to tan inverse of root 3 times of W2 minus W1 divided by W2 plus W1. This is the total power measured by 2 wattmeter method, and this is the power factor angle. By using 2 wattmeter method, we can find power factor as well as the total power. Now let us see what more than this we can find. By using the 2 wattmeter method, we can also measure the reactive power. Root 3 W2 minus W1 equals to root 3 times of W is VL IL cos 30 minus 5 minus VL IL cos 30 plus 5. Now elaborate this. Root 3 times VL IL of cos A minus B, that is cos A cos 30 cos 5 plus sin 30 sin 5 minus of cos A plus B, that is minus cos 30 cos 5 minus of minus plus sin 30 sin 5. These two are similar and opposite. We'll be getting root 3 times of VL IL 2 times of sin 30 sin 5. Thus root 3 times of VL IL 2 and sin 30. Sin 30 is nothing but 1 by 2. 2 and 1 by 2 gets cancelled, and you will be getting sin pi, which is nothing but a reactive power equation, which equals to the reactive power Q. Now we can also find the instantaneous powers by using this method. We will having W1 plus W2, which equals to IR VRY plus IB VBY. Now IR VRY is nothing but VRN minus VYN plus IB VBN minus VBY. IR VRN plus IB VBN minus of this is YN. So VYN of IR plus IB. From the KCL, we can say that IR plus IB equals to minus IY. Now by substituting this here, we'll be getting W1 plus W2 equals to IR VRN plus IB VBN minus of minus plus IY VYN, which is total instantaneous power. Variation in wattmeter reading. We have seen that for lagging power factor load, W1 is equals to VL IL cos 30 plus 5, and W2 equals to VL IL cos 30 minus 5. 5 being the power factor angle. Thus, the wattmeter readings vary not only on load but also on power factor 2. Let us observe a few typical cases to clarify the above facts. Case 1. When phi equals to 0 degrees, then cos 0 degrees, which is nothing but 1, or else unity power factor. Then W1 will give us VL IL cos 30. Cos 30, which is nothing but root 3 by 2, or else 0.866 times of VL IL. And W2 will give us VL IL, so cos 30 again, which is 0.866 VL IL. Or else we can say that both W1 and W2 are giving a positive value. For unity power factor, the power factor angle is 0, and W1 is positive, and W2 is also a positive. Now case 2, when equals to 60 degrees, then cos 60, which is nothing but half, or else 0.5 lag. Then W1 is equals to VL IL cos of 30 plus 60, which is nothing but cos 90. Cos 90 is 0, then this value will be 0, and W2 equals to VL IL cos 30 minus 60. Cos minus 30, we know that cos minus theta equals to cos theta, else cos minus 30 is nothing but cos 30. Cos 30 is root 3 by 2. This is nothing but 0.866 VL IL. So for 60 degrees of angle, 0.5 lag power factor, the wattmeter 1 reads 0, wattmeter 2 reads a positive value. Case 3, when phi equals to 90 degrees, then power factor cos 90, which is equals to 0, or else 0 power factor, then W1 is going to give us VL IL cos 30 plus 90 is nothing but cos 120 degrees. We are going to get minus 0.5 as sin 30. Sin 30 is 1.5, minus value will be there. VL IL, and W2 is going to give us IL VL cos 30 minus 90, which is nothing but minus 60 degrees. We know that cos minus theta equals to cos theta, or cos minus 60 degrees equals to cos 60 degrees, which is half. So 0.5 VL IL. So at an angle 90 degrees, the power factor is 0 power factor. The W1 is going to read us a negative value, and W2 will give us a positive value. Under this condition, W1 would read negative. We cannot measure the negative as the wattmeter reading will be negative, so the needle will go beyond the 0 and it is not going to give us the reading. So what we need to do is, to obtain the reading on W1, it is necessary to interchange the leads of either pressure coil or current coil. So after reversing the leads, we can take the reading, but we need to consider that reading as a negative one. Now for this, we are getting a positive as well as negative values, but they are equal. So we can say that W2 equals to minus W1, or we can say that W1 plus W2 equals to 0. So in between these two angles, 60 and 90, we are going to get a negative value for the W1 and positive value for W2. Simply by observation of the readings, wattmeters, that is wattmeter 1 and wattmeter 2, if both the wattmeters are showing the positive reading, then we can say that the power factor is in between unity power factor and 0.5 lagging. If the wattmeter 1 shows 0 value and wattmeter 2 shows the positive value, then we can say that it is 0.5 lagging. And one wattmeter is showing negative value and another wattmeter is showing positive value, then the power factor is in between 0.5 lag and 0 power factor. By using this 2 wattmeter method, we can measure the power factor, power, as well as the reactive power and total instantaneous power of the circuit. And by the inspection of the wattmeter reading, we can also comment on the circuit power factor. This is regarding the measurement of power and power factor of a balanced 3-phase load. If this video is useful, please like, share and subscribe.